Okay, if you haven't done so already, you need to go on the website and print out those handouts that I have attached with the lesson. We're going to go through these 5 examples together. As I know it's a lot of writing, it might be kind of hard to see here on this video, but we'll pull it up here so you can read it pretty clearly. Let's go through some examples of of interpreting functions that are sort of word problemy. All right. So in example 1, pulled up here, says the cost to manufacture X number of iPhones can be represented by the function f of x. It says if f of 10 is equal to 2,000, then blank number of phones cost blank to manufacture. Notice here what they're asking you in this problem is what we talked about in the previous slide. In this first example, which is the input, which is the output. All right. So if you look at this example, they're saying the cost to manufacture X number of iPhones. So X represents the number of iPhones, and f of x represents the cost. All right, the cost is represented by f of x. Okay, so your input is the number of iPhones. Your output is the cost to manufacture that number of iPhones. So if we have this function f of 10, notice our input is always the thing that's inside of the parentheses. So 10 is the number of iPhones. So our answer here is 10. And they cost whatever our output is, which is 2,000. So the answer to this one is to say, well, 10 iPhones cost $2,000 to manufacture. Okay? Simple enough? Looking at example 2, it says the number of barbecue sauce packets P that McDonald's produces determines the number of trucks needed to haul them. The number of trucks needed can be represented by a function f of p. If f of 1,000 is equal to 2, then blank number of barbecue sauce packets create demand for blank number of trucks. Okay? So notice here that our little p thing is our input, and that represents the number of barbecue sauce packets. And they say that up here. The number of barbecue sauce packets, P, the number of barbecue sauce packets is P. And P, if you notice, is in parentheses, so this is our input. All right? So our input here is basically going to be the thing inside of the parentheses. The number of barbecue sauce packets then is going to be 1,000. All right? Our output is the cost or the number of trucks. All right, the number of trucks is represented by f of p. Okay, so our output, the number on the right hand side of the equals is 2. That represents the number of trucks, so it creates demand for 2 trucks. Okay, looking at example 3, a local sub shop sells foot-long sandwiches for $6 a piece on Monday nights. At capacity, the sub shop only has the materials to make 500 subs. The function f of s equals to 6s represents the amount of money the sub shop takes in on Monday nights, where s is the number of subs sold. What is the domain of f of s in this context? So the key to this one is that word domain. Remember, domain always represents input. And input is always the thing that's inside of the parentheses in function notation. So S is the domain. Now we have to read the rest of the problem to figure out what our limitations are on that domain. So in this case, the limitations on our domain is going to be based around what S represents in this problem. So in this case, a local at capacity that the sub shop only has materials to make 500 subs. S represents subs, okay? Where S is the number of subs sold, all right? Notice S is the number of subs sold, and they only have the materials to make 500 subs, okay? So your domain in this case, it can only go up to 500 subs. Now notice, though, if you think about it, you can't have less than 0 subs. You can't have a negative amount of subs in the store. So your domain can't be negative. It can't be negative. And it can't be greater than 500 because they don't have any more materials than that. So what you can say is that your domain is from 0 to 500. All right? That's what they're asking for. Domain is from 0 to 500. You can't have more than 500 subs. You can't have negative subs. So S can only equal 0, 1, 2, 3, up to 500. That's all S can equal in this problem because that's the limitations put on it by the problem. Okay? Let's look at number 4, which is going to be similar to number 3. A goat is walking from one edge of the farm to the other. The distance in feet of the goat across the farm, of the goat walking across the farm, can be determined by this expression, 2t plus 10, where t represents the time. So t is the time at any given moment that he's walking. So what is the meaning of 10 in this expression? This sort of goes back to what I said in this final thing here, this final little point in the previous video. If we consider this function, the mx part, the part where you're multiplying two terms together, that causes the function to grow. But the part on the end here, that represents the initial value. So if you look at the function that they give us here, 2t plus 10, let's look at that. 2t plus 10, and in this case they don't give us function notation, but let's say our f of x is equal to 2t plus 10. That's our function, okay? So this part, the 2t, causes the function to grow, and this part represents the initial value. Okay, so the initial value, and they're asking what does 10 mean? Well, 10 is the initial value, but in this case the initial value is represented by distance. So that means that the goat is 10 feet from the fence or wherever he started. 10 feet from starting point. Okay, so basically what that 10 means is if this f of x is representing distance, because the distance in feet can be determined by this function. So distance is f of x, then the 10 here has to represent distance. And this also goes back to what I said in word problems and stuff like that, where I said every term in that problem has to be of the same unit. So if f of x represents distance and 10 is the only thing here by itself, then 10 must represent distance as well. So the goat is 10 feet from the starting point or whatever. Okay? Finally, example 5, which is going to be similar to example 4, says an astronaut mechanic is climbing along the side of a spaceship to make repairs. The height in feet of the astronaut above the ground after t minutes can be determined by this expression, negative 10t plus 20. What is the meaning of 20 in this expression? Okay, so they're asking us the same thing they asked us here in the goat problem. We have to figure out, first of all, our function f of x is equal to negative 10t, or in this case it'll be f of t, and up here it'll also be f of t, negative 10t plus 20. All right, that's our function. F of x represents the height, the distance, and t represents time. Okay, so in this case, this function here, our t is time. This is a unit of distance, again. So this 20, being that it's the only thing left on the end, must also represent distance. Okay? And 20 represents a distance. Well, what does distance mean in this problem? Well, an astronaut mechanic, he's climbing up a spaceship. So that means that the astronaut starts climbing 20 feet off the ground. All right, so basically he must be up in the top capsule or somewhere in the middle, and he climbs out the door and starts climbing up the spaceship. Okay, so 20 here represents distance. That's the initial value. That's the initial point at which he climbed out of the spaceship, and that 20 would be distance from the ground, or the height from the ground. So that's what that represents. If you have any questions on these problems, please bring them to class.